So the 8-3 homework is 17 questions, and I looked at it yesterday. You should, at this point, be able to do 1 through 12. We've covered graphing complex numbers, finding the absolute value, writing the trig notation, multiplying when it's in trig form, dividing when it's in trig form, and the only thing that's left is raising it to a power, which I'm going to show you. It's just another formula. I want to go to this page. Let me find it. Okay, this page right here. So this is where we left off yesterday. Example 6 is multiply these complex numbers together. And then, so when you're doing this, like when you take this test, when you read this question, your first instinct is probably first, outer, inner, last, but go to the directions and it's going to say to you that you're finding the trig notation, which is your indication. Don't first, outer, inner, last this. You know, this is the trig stuff. You need the trig formula. So we pulled the trig notation for both of those from the previous example where we had already found it. And then to multiply them, you have to use the formula. You're not actually, first, outer, inner, lasting anything here. You're using the formula, which will be given to you, and plug it in. We came to 2 root 2 cosine 375 plus I sine 375. 375 is bigger than a 1 full rotation, so it makes sense to say, let's calibrate that. And so we pulled up the unit circle and said, if you do 360 and then go just a little further to 375, you've just gone an extra, a 15-degree reference angle, right? So that's where we said this is actually the more simplified form of the answer. And we can't find cosine and sine 15, so we stop there. We can't put values in because we don't know what they are. So that was the answer. So that. Coming to this one, convert to trig notation and multiply. So this is the exact same type of question, but I pulled some complex numbers that we have not already put in trig form. So this is a good question that kind of practices everything that we've done so far. So let's do this one together. This is going to get crowded. Don't write big here. Okay, so if I'm just focusing my attention on 3 square root 3 minus 3i, I'm going to focus my attention on that, right? What is A? A is going to be the one that does not have the I attached to it, the real number. And then what's B? B is always the coefficient of the i's, and it goes with the sign, so it's -3. So if we're writing this in trig form, if you remember from, like, I think it was the second or third slide, we need to find R, then we need to find the cosine and the sine fractions, then we find theta. Okay, so R is the square root of a squared plus b squared. A is 3 root 3. B is -3. Remember what I said about putting it in parentheses. If you will use the parentheses, then you can go to your calculator and you can type just the radicand in, and you'll get exactly what you should get, like you'll get the right answer. Just remember, don't enter that giant square root in the outer, because then sometimes you might get decimals. So if you go to your calculator and you enter parentheses 3 root 3, close parentheses squared, plus parentheses, negative 3, close parentheses, squared. You should get 36. Double check that. Make sure you can enter that correctly. And what is the square root of 36? 6. So R is 6. If you recall, we had to find R. Done that. We have to find the fractions for the cosine and the sine. So set it up. Cosine of theta is A over R. Sine of theta is B over R. I'm going to write it right here. Plug it in. A is 3 root 3. R is 6. B is negative 3. R is 6. Reduce those. Be careful reducing right here. This 3 in the front of the radical would divide into the bigger number, the 6, and leave a what behind? This 3 would divide into the 6, leaving a 2, right? This would divide in here and leave a 2. So that's square root 3 over 2. This would be negative 1/2. So the question is, this is where I always say to myself, okay, my big question is, what angle has a x coordinate of root 3 over 2 and a y coordinate of negative 1/2? Well, if x is positive and y is negative, that means I'm in quadrant 4. And it's, what is it? 330. So theta is 330 degrees. So I have no room down here. So I'm going to come right up here next to this, and I'm going to just put equals, and I'm going to write the trig notation of that first complex number. So the trig formula, when you're writing the notation, is R parentheses cosine theta plus I sine theta. So my R was what? 6 parentheses cosine, my theta is 330 plus I sine theta. So that's my first trig expression. And you could put brackets around it if you don't like the double parentheses. I just tend to make them bigger as I need more so that I can keep track. Now we're going to repeat. I'm going to draw lines. We're going to repeat now with the complex number 2i. What's the real number in that? 0. So A is 0. B is 2. Find R. Square root 0 squared plus 2 squared. You get square root of 4, which is 2. Right? Okay, let's find our angle. Cosine theta is A over R. Sine theta, B over R. A is 0, R is 2, B is 2, R is 2. 0 over 2 is 0. And 2 over 2 is 1. So you can probably do this one in your head. If it's 0, 1, that means no right or left movement. You just went up. So that's the 90, and so theta is 90 degrees. So now I'm going to come right up here, and next to this, I'm going to put really big parentheses, and I'm going to rewrite this complex number in my trig form. So that's r cosine 90 plus I sine 90. Now, if the directions had said convert to trig notation, I would be done. But they say convert to trig notation, then multiply. And remember, you're not multiplying the way you normally think you would. You're going to go to your formula sheet. You're going to find the formula that shows that they are multiplied together. And now we're going to plug it all in. Okay? So I'm going to draw another line. The formula is R1 times R2 goes in the front. Then it's cosine, add the angles, plus I sine, add the angles. So I'm just going to write it all down. R1 was 6, R2 was 2. You could go ahead and multiply that. I'm going to show where all of my numbers come from, though, so in case you're confused. Theta 1 was 330. Theta 2. So this is 12. Cosine 330 plus 90, 420. Now, like in the last problem, we've just gotten a theta value, an angle that is beyond one full rotation. So we need to calibrate this down to a number between 0 and 360. So find the coterminal angle by taking 420 and subtracting off a full rotation. So 420 minus 360 is 60, and I'm going to make a note here. This is our reference angle, or you could say coterminal angle. Now, in the last problem when we got here, we were done because you don't have 15 degrees on your unit circle, right? So you were done. Do we have 60 on the unit circle? Yes. We're not done. We need to replace cosine 60 with the fraction that, the x coordinate, and sine 60 with the y coordinate, and clean it up. So if you go to your unit circle, chapter 6. Go to your unit circle, find 60. The x coordinate's 1/2. The y coordinate is square root 3 over 2. So in here, I'm going to replace cosine 60 with 1/2. And sine 60 with square root 3 over 2. You can put the I after it if it bothers you to have it in front. And then now multiply the 12 in. So 12 times 1/2 is 6. Be careful here. Can't type this in the calculator because of that square root of 3. Here's what you can do. Take the denominator, divide it into the number that's multiplying in. So 2 divides into 12, leaving a 6 times root 3. They just shove together. So 6 root 3. And then, of course, you have the I. Now, that is a college level math problem. At any point, was it something that was challenging? Probably not. It's probably just a matter of exhaustion. because you got to find this, then you got to find that, then you substitute it in, then you got to find the formula, then you got to find the reference angle, then you got to find the x and the y, then you got to multiply. So it's not necessarily that it's hard math, it's just a long math problem. And it's something that, like I've said before, it's foreign. You're not used to working with trig notation of complex numbers. Okay, go to the next slide. This. Not in the middle of yours. Yeah, okay. I must have pulled it. All right, so when we did the division one yesterday, we only had one practice problem. So here's another practice problem. And it says convert to trig notation and divide. So this starts out right where we just left off. Let me see. We already have 1 plus I in trig form. You have 1 plus I in trig form on example 3a. So pull your trig form for 1 plus I from example 3a. So I'm going to come right here. This tells me clearly I'm dividing, which means I would need my division formula for trig form. 1 plus I in trig notation, we found it to be root 2 cosine 45 plus I sine 45. That was in a previous example. Now we have not found 1 minus I. So we need to do that. So let's come over here and let's find 1 minus I. So I want you to do it. Label A, B, find R, find the fractions for cosine and sine, find theta, and then plug it in. right, you have the trig notation for for 1 minus I. I'm going to write it, and if you didn't get it, then I will work it out. Did you find r to be square root 2? And did you find theta to be 315? Yes? Now, if you're wondering why 1 plus I and 1 minus I have the same r, that's because, remember in the formula for r, they get squared. So signs become irrelevant. So that's why they have the same r, but they yield different thetas because when you're looking at theta, signs are important. That lets you know what quadrant you're in. Okay, does anyone need me to work how I got the trig notation of that? You good? Okay, so now that we have the trig notation, we're going to divide them. We don't divide like we normally think we would. We divide by using the formula. It's right here. So the formula tells me, take the two r's and divide them. And then bracket cosine. Take the thetas and subtract them. Order matters here. So the one on top minus the one on bottom. Root 2 over root 2 simplifies to a, what? Oh. Don't get bogged down in it. Does the top match the bottom? Yeah, so don't get bogged down in it. I think you actually could double check that in your calculator and it should tell you 1. But root 2 over root 2 becomes 1. I'm going to write the 1 there, but it's irrelevant. And then right here, cosine 45 minus 315 is negative 270. Because it's negative, I'm going to put it in parentheses so that I don't get confused here and think that it's cosine minus 270, which would be impossible. All right, and then plus I sine negative 270. Now, negative 270 is outside of our 0 to 360, so we need the coterminal angle. So take negative 270 and do what with it? Add 360. That's going to give you your reference angle. Spell it right. Reference angle. All right, and you should get what, 60? No, not 60. 90. I'm going to drop the 1 because it was irrelevant. And then 90 is on the unit circle, which means keep going, replace it with the fractions. Well, the 90 is a quadrantal angle. You probably could do this in your head. 90 is up here, so that's 0, 1. So the x coordinate is 0, and the y coordinate is 1, right? And as weird as this looks, 0 goes away, and I times 1 is 1i, or just I. So my answer here, and I've run out of room, is I. Okay, I want you to do E5. The trig notation for 1 minus I is up here, right? 1 minus I, the trig notation is that denominator. And the trig notation for root 3 minus I is, lost it. Root 3? Wait, root 3 minus I.
Yeah.
Oh, we used it on another one?
Yeah. Root 6.
Yep, I see it now. Okay. It's also somewhere else. Yeah. So, pull your trig notation for 1 minus I. Then pull your trig notation for root 3 minus I. And then now apply the formula to divide them. Listen. Did you get square root 2 over 2 cosine 345 plus I sine 345? Did you get that? Why can I not go any further? 345 is not on the unit circle, so you would be able to stop here.
So you take away the square root 2.
No, the only reason I took it away up here was because it was the number 1, which would not change anything when I multiply that in. But you don't multiply that in until you find the fractions of the sine and cosine.
The top one was square root 2 over square root 2.
Guys, can I show y'all real quick 9A? Because it's not bad at all. Can I show it to you? Do you mind?
Yes.
If I ask you to take a trig notation, oh Lord. If I ask you to take a trig notation and raise it to a power, again, there's just a formula. So if you look right here, this is saying if you're raising it to a power, then it just changes the R by raising the R to that same power. And then right here, whatever the power was, multiplies in front of the theta. So let me show you what that would look like. If I said evaluate 1 plus I to the 9th power, that lets me know that my power here is 9, right? 1 plus I, we already found the trig notation for that in a previous problem. So the trig notation for that is the square root of 2 cosine, I think it's 45, yeah. Alright, so now look at the formula to raise something. There's my trig notation to the power of 9. I would apply the right side of the formula, which says take R, raise it to that power, then write cosine the power times the angle plus I sine the the power times the angle. I'll let you go. I'll finish it.